Hi, this is DC here. Welcome to the second video on OMNIKEY 5422 reader writer. In this video, I'm going to show you how to use the SLE4428 or 5528 contact memory cards. So I've made many videos on SLE4428, 5528, but using a different types of readers like ACR38 and ACR39 and OMNIKEY 3121. All these videos are available in my video channel. You have to get the documentation of this OMNIKEY 5422 as well as the data sheet of SLE4428 chipset. And you have to read a few important sections from the OMNIKEY documentation. So there is a section called vendor specific commands. There's a section called synchronous cards. You just have to go through a few examples there. And in the last video I showed you can download a project from OMNIKEY website that shows you how to program using this 5422 reader writer. And you have to read the the chipset documentation, and you have to understand the command structures of various commands of SLE4428. If you go to my video channel and look for a playlist called Understanding and Programming Contact Memory in Smart Cards, I have made few videos long ago on how to use SLE4428, 5528. It's over here, and you also got one over here as well. Plus I've showed you how to use food and 5528 memory cards, and I think this is using the OMNIKEY 3121 reader writer. And obviously if you have a reader writer, you will have this documentation got from OMNIKEY website. This is the chapter I mentioned about the vendor specific commands. So you have to read this and understand. And also I'm going to show you how these commands are used in my videos. So there is also an example. If you go to chapter synchronous cards support, there's a nice example that shows how to use this 2-wire and the 3-wire cards. The SLE4428 is a 3-wire card, and look at it. This is an example of how to use SLE5542 tags, and here's an example on how to use this 4428 cards. This is the command structure you have to use in order to read and write, and also to use various other commands. And you have to get this. If you want to know in more detail about the various commands, and if you are a programmer or if you come from programming background, reading this documentation is going to be helpful. So here they explain how the various command structure. You can ignore all these type of wave diagrams, but you have to focus on the command structure. So like something like this. So here now you can see all the commands of this chipset, and also the command bytes and what are the parameters. So with this background, and I'm going to go through an example using a brand new SLE4428 tag. You can see here I've connected my OMNIKEY 5422 reader writer, and this is software we've been using in all my previous videos. SLE4428 reading and writing is available in version 1.7 of this software. Now I'm going to use a brand new SLE4428. So if you want to buy this SLE4428, look in Amazon.com. You can see some good pricing out there. So as soon as you click connect, based on the ATR, this screen pops up. And if you want to know what the ATR is, if you hit this ATR button, you can see this is the ATR of this SLE4428. So first I'm going to show how to use these type of tags, and later on I'm going to show you some of the commands and probably will go into detail which will be useful for the software developers and students of technology. Now when you hit the read button, this takes more time. If you look at here, it is just it will flash for probably 45 seconds or a little more than that. So the reason is this tag has got 1 kilobytes of memory or 1024 bytes of memory, and the command allows you to read only 1 byte at a time. So if you look at the PDF documentation of this chipset, there is a command to read just 1 byte. So it has got 1024 bytes of data, and every byte has got its own log bit or the protection bit. If you compare this with the SLE4428 tag, which had 256 bytes of memory, where only the first 32 bytes are lockable. You can call these bytes as a lockable, or documentation call this as a protect bit. Actually this is a bit. Internally it is stored as a bit. So however, there is no command to read individual bit. Now I'm going to go through this in a detail later. If you look at the command structure, you will see there are 1024 entries, or 1024 commands are sent to read 1024 bytes of memory. Now on the screen on the left side you got the data, on the right side you got the corresponding protection bit. Again, I'm not going to go through in detail now, because as I mentioned before, I already have 4 videos on SLE4428. So just like the 4442 tag, this tag requires authentication before you can make any changes. Here the authentication are 2 bytes long. Compare this with the 4442 where authentication was 3 bytes long. Now if you look at the documentation of this chipset, it mentions the last 3 bytes of the memory is where the error counter and the password authentication code is stored, and you cannot read the value of this authentication code. If you try to read, you will get zeros here, as you can see here. For all new tags, the default password is all FFs. In fact, the entire memory, apart from the first few bytes here, is initialized with the FFs. FFs are the hex equivalent of all binary 1. Now before I'm going to write, so I'm going to show you how to authenticate. So if you hit this button, probably before that I'm going to clear the memory. So I'm going to authenticate. Now authentication is successful. I'm going to write something in this third row, and because every byte is addressable. The first byte has address 0, second byte address 1, and third byte address 2, and so on. So I'm showing 16 bytes in each row, whereas this R link is to read the 16 bytes from the card, W is to write the 16 bytes, and E is to edit 16 bytes. So I'm going to edit. If you click on E, I'm going to just type all A's. So we have authenticated. That means we can save these changes. If I hit W, now you can see that the data is written. To verify the data is indeed written to the tag, if I hit the read, you can see that it is still 66.1. So it's a very simple operation. You just have to authenticate before you make any changes. So I while doing this, I have to in fact, I've made almost more than 5, if you can see here, more than 5 tags. I made them unusable because of the writing in the last page. So I made some changes in this version compared to the previous versions. So now if you edit and save, the software saves only the first 13 bytes. Otherwise, it will end up saving whatever value you add here, which will change the error counter as well as the password. So that's all. It's a very simple tag. Let's see, how do you lock? Now locking in this tag can be done in 2 different ways. It's all possible because of the way the reader writer command set. This 5422 is much better in programming SLE4428 compared to the other devices I have shown before, because you can use all the commands of SLE4428. So I'm going to do exactly the same thing this time. Writing, I'm going to edit, set all to B. Now I'm going to tick this mark, tick this checkbox, write and protect as well. So what it means here is, there is a command set in the chipset documentation that will automatically lock after writing to the bytes. If I hit write, now write is okay. However, I'm going to refresh this corresponding row on the right side. If I hit say R here, you can see that automatically all these bytes are locked, and the lock is a one-way locking. You cannot unlock. You can never ever unlock this data. So which is very easy to lock the data. You can also lock the data in a different way, which is called compare and lock. Now I'm going to show you that as well. So I'm going to modify the next row. First I'm going to do a write operation. It's all written now. I'm going to go to the corresponding row and say I'm going to lock it. I can individually select which bytes I want to lock. Then I'm going to hit the W. Now here the locking is done. However, looks like there is a small bug in the program. Let me check, read. Yeah, this is obviously now a bug here, because I didn't wanted it to lock these bytes. So I need to check this software for that. Let me try this again. So edit the 80 row with the E. So I'm going to write. Let me clear this memory. Now I have got this 80 memory. I'm going to lock just a few of them. I'm going to hit the W. So here, obviously there must be a bug. Probably, by the time you get this software, this bug will be okay. Now that's all. You got, plus what you also have here is, you can also change the error counter. I think this is a bit of an advanced level at this stage. So next I'm going to show you how to log. Say I want to log right from here to here. So the way you do that is, first we write the data. Yeah, sorry, now I know what is wrong here. Okay, so when we try to save this row, the write protect, it was ticked. So my apology for that. It's not the bug here, it's the way I was using this software. Now I'm going to untick that. So let's try with one more row. I'm going to type Fs. Okay, I'm going to write. Now this way of writing is writing without the protect bit set. Now I'll show you later. I'm going to show you now what exactly this means when we look at the command set from the documentation. So I'm going to clear this. Now I'm going to go to on the right side. I'm going to lock the first 3 bytes here. I want to lock 3 bytes here, probably the last 2 bytes. Okay, I want to lock only certain bytes of the memory. If you noticed here, as soon as you click, the color of this changes as well. That's what the software is doing. Now when I hit this W, now the write protection command is also called as compare and protect command, is sent for only those things. If you look at here, so we are not sending 16 commands, just very few commands here. So once we did that, if I go and read, you can see that only these bits are locked. So it's very straightforward, but you have to keep in mind, before you lock or before you write, you must have the authentication done. Now what's going to happen to the system, what's going to happen to the card if I did not authenticate? Let's give it a try. I'm going to reinsert the tag, connect, read. As you can see here, so still the reading is going on. I will notice something. If I try to read the same tag using the ACR38U or 39U, it's much quicker there, because in ACR38U there is a command to read 256 bytes at a time. So I'll end up doing only 4 reads there. If you see my other videos, you can see how quick it is. Now I'm going to modify a few bits here. So before that, I'm going to clear. So write. Now you got error message, write error. So that is because we are not authenticated. Now if you look at this documentation, sorry, if you look at the command and response, so this shows the write was not successful. So before you write, I'm going to authenticate. So we have seen how the authentication works. Let's give a write here. Now edit, give a write. So the write is okay. Now I'm going to show you what's going to happen when the authentication is not right. So at present, as soon as authentication is successful, you can see this entry success, 7 tries left. The documentation says you can go up to 8 retries. Somehow I can't get the 8. I just can go up to 7. So let's try this again, because we already authenticated once. So reinsert. Whenever you change the tag, you have to start all over again from the connect, because we are using the PCSA, the commands from Windows as card library. So I'm going to read. You don't have to read first and authenticate. You can authenticate first. If you know the password, then you can give a read. I'm going to read. I've also provided a button here called read protection bits. This button was there even for the earlier readers, so you don't have to use this in this version, because the read data will also read the protection byte as well. But if you can still try it. If you hit the read protection bits, what the software does is it reads again, it goes through the same 1024 times read cycle and extract out the log bits. In most of these type of tags, the first two rows are used for some personalization. It could be the customer ID, or it could be some kind of a auto generated a unique ID for the card. At present, this what you see here matches the ATR. So if you see here, the last 4 bytes matches the first 4 bytes here. Now I'm going to authenticate. You just keep looking here, the retries. So I'm going to authenticate with the wrong password. Say F1 authenticate. So authentication error. Look at the retries has gone down by 1. You have got 6 tries left. Try F0. Authenticate, it's gone 5. Try F1. 4 tries. F2. You got 3 more tries. F2, F4. You got 2. You can go last. If you try now, so this card is going to become read only. So I'm not going to do that. Probably do that in the next part of the video where I speak about various commands. Now I'm going to authenticate. Once the authenticate is successful, you get back those 7 tries again. Now we have authenticated the tag. I can modify the password, but again, anything you want to write except maybe writing for this error counter, you must authenticate the tag. Now I have authenticated. I'm going to change the password to EAA. Change the security code. See, from this point onwards, your password is now EAA. Now I'm going to try that. So we're going to pull it out. Try again. Connect. The authentication obviously is an error. I'm going to try EAA. You authenticate successful. Now if I just go and hit the read protection bits, it's still using the same command to read the data. Now I'm going to show you in the next video that reading the data from using the commands in this 5422 device, you'll get both the data as well as the log byte. So you get 2 bytes for every read operation. So at present, when you hit this read protection bits, so nothing is shown here. However, a lot of read commands have gone. It is because there's no the data read. That's the reason why you don't see the protection bits. Now at any given point of time, you can hit this read, so you can know how many error counter or how many attempts are left in this tag. You can also write. So assume that you're a software developer, you have customized this tag, and you want the users not to have 7 attempts, but you want them to have 3 tries left. Now I can hit write. Now it says error change error counter is done. And again, keep in mind, so you don't need, in fact, you don't need any authentication to change this error counter. So what we have done just now is, from this point onwards, you have got only 3 retries before the tag gets permanently locked. Let's give it a try. So if you read, you can see that the read command is showing only 3 retries. Okay, so that's how you use this SLE4428 or 5528 tags. In the next video, I'm going to speak more about the commands and the command structure, what exactly is happening within the device. I think the next video will be useful if you're a software developer or if you're a student of technology. Thanks for watching.